Hello, so today we're going to talk about direct variation and how that relates back to our linear functions from previous sections. So a direct variation is described as an equation of the form y equals kx, where your k does not equal 0. Otherwise you just have y equals 0 and the equation is simple. K is called the constant of variation. Now this is going to be constant no matter what x and y are, so it depends on each particular problem. K can also be considered the slope of this equation. So if you were to graph these equations, it is pretty much in the form of y equals mx plus b, where b is 0, so you would start at the origin, and k represents your slope, where you go up and down, left to right. So we're going to use this y equals kx concept to solve different types of problems. So suppose y varies directly as x, write a direct variation equation that relates x and y, then solve for the missing piece. So what we want to do is we need to use the first information, y equals 10, and x equals 4, to solve for k. So we're all basing this off y equals kx. So y equals 10, and x is 4. So we need to divide both sides by 4 to solve for k. And we get 5/2 for k. So the first part, so our equation would be y equals 5/2 x. This would be my direct variation equation for this particular situation. Now that I have my equation, I just need to plug in 8 for y and solve for what x would have to be for this case. So 8 equals 5/2 x. In order to get rid of the 5/2, we have to multiply both sides by 2/5, the reciprocal of 5/2. This gives us 16/5 for x, and we are done. So this is a very straightforward process. All you need to do is solve for the k part first, using your initial y and x values to write then your equation y equals kx, whatever the k value is. And then plug in the second piece. I'll give you a y or an x, and you need to find the other missing piece. So here, y equals -15 when x is 30. Find y when x is -4. So again, we plug into our y equals kx equation. So -15 equals k times 30. So when I divide both sides by 30, k equals a -1/2. Which means my direct variation equation is y equals -1/2 of x. So now I need to find y when x is -4. So we plug in -4 into our direct variation equation. -1/2 times a -4 is a +2. So y equals 2. One more together, then I'll have you do on your own. So y equals 3/4 when x is 4.5. Find x when y equals 9. So for this particular problem, we're going to rewrite our mixed number as an improper fraction. It's a little bit easier to work with in that case. So we have our y equals kx original equation. So 3/4 equals k times 9/2. So to solve this, we have to get rid of our 9/2, meaning we should multiply by the reciprocal 2/9. When I do that, you'll find k to be 1/6, which tells us our original direct variation equation, y equals 1/6 of x. We're now going to take that 1/6x, plug in y equals 9 to solve for the x. So it'll be 9 equals 1/6 of x. Multiply both sides by 6 to get rid of the fraction. So x equals 54. So again, as I said, just to summarize, you're going to take your x and y initial values, plug them into y equals kx so you can solve for k. Once you have k, you rewrite your equation using the k, so y equals whatever that k value is times x. And in the last part, I'm going to tell you either an x or a y value, solve for the missing piece. So you're going to plug in whatever I tell you to plug in, and then solve for your missing variable. So go ahead and do this one on your own. Get me a value for, get the original direct variation equation, and then go ahead and find the y when x is -8.2. So go ahead and pause the video while you work that out. Alright, so you should be getting these two answers. Your direct variation equation with your k value should be y equals -0.4x. And then when you plug in -8.2 for x, you should get y equals 3.28. Now notice for this problem we use decimals instead of fractions. The reason why, you're given decimals to begin with, so that's why I want to leave it as decimals. If I gave you fractions to begin with, you should try and leave your answers in fraction form, especially for ones that cause repeating decimals. It's much easier to work with. Alright, so that's your direct variation. I will see you next time for the rest of the stuff on linear functions.